So this is Goodbye YAML, Infrastructure as Code in Clojure. Before we start, though, I'd like to quickly thank Kim Foster and Alex Miller for doing all the work of organizing this conference. I've been to a number of conferences, and I've never been to a Clojure conch before. This is my first conch, and I have to say I really like the tone. It's a very thoughtful audience, very thoughtful conference. So thanks a lot to Kim and Alex for making it possible. And of course, all the people at Cognitect for sharing this great language with us. It's brought me a lot of joy in my life. So my name's Eno. Joining me on stage a little bit is going to be Tyler. There's our email addresses if you want to ping us later for questions. This talk is basically in two parts. It's a story of a library, and it's a demo. I'm going to be telling the story of where this library came from, and Tyler's going to give you a feel for what it's like to use the library. So the story starts at Stedi. It's an early-stage startup located in Boulder, Colorado. We've just raised our Series A of about $14 million in funding. And at Stedi, we're building a global network for B2B structured communications. And that's kind of a dense sentence with a lot of meaning and a lot of words packed into very few letters. So if you go look at our website, it says this, the structured messaging platform for B2B trade. And it helps, I think, to kind of unpack this, because that will help to understand where this library came from and also, just what this company is doing in general. So if any of you have ever worked in purchasing or fulfillment, or you have a friend or you know somebody who's doing that work, then you probably know that a lot of the business processes that people are using to do purchase orders, invoices, ship notices, all kind of things that businesses, any kind of structured communication that one business is sending to another, the systems that are facilitating that communication are incredibly archaic, often painful, tedious, and what we're talking about here is it's a $1 trillion market. Any kind of physical item in the world is touched by these archaic processes. The clothes you put on this morning, the breakfast you ate, the laptop you put in your bag, everything is touched by these business processes. And even in the most extreme cases, what we're talking about is people bringing home, giant stacks of paperwork with a ruler and a red pen and literally going line by line by line to make sure an invoice is properly fulfilled or a purchase order is fulfilled or whatever. So at Stedi, we're trying to make this, we're trying to fix this, trying to make it better. So in effect, what we're building is, a digital mailbox for any kind of structured communication between businesses. We're doing it 100% in Clojure, and we're using AWS serverless to do it. So like I said, Stedi is located in Boulder, Colorado, which in my opinion is one of the best places to be writing software on earth. We have a 12-person team, and we're growing. So if you'd like to hear more about that, Tyler and I will hang out afterwards. We're happy to talk with you. So this is basically the bread and butter of what we do. We're using Clojure to solve real business problems, and we're deploying it on AWS. And this is basically what we do every day. Now, just as Rich chose Java for Clojure, we like to think that we chose AWS for infrastructure. So, the whole question of multi-cloud and all the related problems that go with that, I'm just going to put that aside today, and I'm going to be focusing squarely on AWS. We've adopted AWS, and our whole world is AWS, so that's going to be the focus of this talk. Nonetheless, some of the things I say I think will be relevant for the experiences of deploying on other clouds. So like I said, we like to use Clojure to solve real business problems and then deploy it on AWS. And in particular, what that means, or not just AWS in general, but we're using AWS Lambda, which is AWS's serverless offering, and it has all sorts of interesting characteristics that kind of change the way you think about problems. Instead of having these long-running JVM processes, we have these short-lived processes and cold starts and all sort of new things that make a lot of new things possible as well. Now, one of the things that we're using to do all this infrastructure is this tool called AWS CloudFormation. If you're not familiar with AWS tools, you might have heard of Terraform. It's in effect AWS's version of Terraform built in-house. AWS describes it as a common language to describe and provision infrastructure. And that language is written either in YAML or JSON. So for this talk, I'm going to be talking about YAML in particular, but every time I say YAML, you could very well think I said JSON, and the same will apply. Now, the nice thing about this tool is, at any moment, a developer can open a text file and look at what the production infrastructure is. We've been very rigorous at Stedi that we want to have all of our infrastructure codified in CloudFormation. And that personally helps me sleep well at night because I know there's not any kind of state lurking out there. It's all described in these nice files that we can change and make new infrastructure, tear down old, and it's all codified in a single place. So it's a great tool. And so we've been using it. We've been writing some Clojure. We deployed on Lambda, and things are good. Then we did that some more. And then we did that a lot. You can see ClojureScript is sprinkled in here and there where we're particularly concerned about cold starts. And along the way, we've learned a lot about what it means to take Clojure and deploy it on Lambda. So this is kind of the world we lived in initially. It was great. We wrote some Clojure, had a great time, put it on Lambda, solving real business problems. And we wrote some YAML too to do that. And some time went on, and then we wrote some more YAML. Wrote some Clojure, deployed it. We wrote some more YAML, some Clojure, deployed it. Then we had a lot of YAML. It was nicely organized, but it was a lot of YAML. Then we kind of had a big pile of YAML. And then it felt like we had this huge thicket of YAML. There's Clojure in there somewhere, but it felt like to get to the Clojure, we had to fight our way through a lot of YAML. And that's not a great experience for some reasons that I'll talk about. So when we realized that we had this huge mess of YAML describing all our infrastructure, and when we realized that we just weren't, we weren't totally happy with that experience, we stopped and looked at our tools. So the first thing we looked at was Clojure, and we thought, well, Clojure's great. We actually really like Clojure. We feel like we're productive. We enjoy using it. We looked at ClojureScript. Same kind of thing. We like it. We're productive. We enjoy using it. In fact, if you go look at the Clojure webpage, you'll see this quote from Rich, where he says, "I hope you find Clojure's combination of facilities elegant, powerful, practical, and fun to use." And in our experience, Clojure and ClojureScript have been exactly that. Elegant, powerful, practical, and most importantly, well, for the selfish developer in me, fun to use. It's fun to write Clojure all day. And then we looked at YAML, which is the other thing that we were using. And in a lot of ways, YAML was just the complete opposite. The experience was completely different. The feeling of using it was completely different, such that you could even graph it like this. You have all the fun stuff in the upper right, fun to use, productive, and then you have YAML in the lower left, which is, I don't personally enjoy using it. And we found that when we wanted to make a small change, or maybe add some new infrastructure, it would be a day, several days, a week. And there's just this feeling inside of not being super happy when you're doing that. And a big part of that is, syntax errors. It's a white space dependent language, which I'm generally terrible at. But more importantly, we'd make a mistake, we'd push it out, we'd wait 5 or 10 minutes for CloudFormation to deploy the infrastructure and say, hey, you got a mistake. You forgot this one required property. Or you got one space and I need 2 here. And that's a really terrible feedback loop. And that just kind of compounds, as you're trying to work through a problem, this slow feedback loop just keeps getting bigger and bigger and bigger, which is why YAML is not as fun to use as Clojure and ClojureScript. So if you think about this for a moment, it's because YAML has in effect become the assembly language of cloud infrastructure. If you're putting anything on the cloud today, I'm fairly confident to say that you're probably using YAML in some capacity. Or to change the wording, to put it in JVM nomenclature, you could say that YAML has become the bytecode of cloud infrastructure. Now, if a person came to you and said, I'm going to write all my application code in bytecode, you'd probably say, I'm not sure that's the best idea. And the reason for that is that we're working with two layers of abstraction here. YAML is kind of a lower level concern, and Clojure is a much higher level concern. And all the properties of those 2 layers are with that. So, for example, when you're working in YAML, you're almost certainly having to be much more verbose and have to write a lot more lines to get stuff done. Whereas if you're working in Clojure, you're able to get wonderful things done in a very concise way, which I think is a large part of why Clojure is such a joyful language to use. So this is the world that I think a lot of developers are living in. We at Stedi were certainly living in it for a while, in that we wanted to be solving business problems and deploying it on Lambda, and yet we had this thicket of YAML in front of us that it's kind of hard to see what it is that we're excited about anymore. This is the world that we want to live in, I think. We want to be focusing on solving our business problems with Clojure and then getting it out to our customers. So there's also a bigger problem here, though. I mean, there's the problem of the levels of abstraction, and you know, some people don't love YAML, but there's actually a bigger problem here, and that is, how are we going to make infrastructure reusable and shareable across teams, across deployments, across companies even, while maintaining the elegant and powerful facilities of Clojure? So in the process of building all these systems using Clojure and deploying it on Lambda, we've learned some things. In fact, along the way, we realized that there were some patterns emerging in our application infrastructure. So let me walk you through what I mean by that and give you an example. So one of the patterns that we've used in our infrastructure that we found is very useful is having a Lambda that consumes events and takes some kind of action based on that event. So we have some Clojure, we have a Lambda, we have an SQS queue that the Lambda is consuming events from. We have some source of events, CloudWatch events, for instance, that are originating elsewhere in our system. It's not important where, it's just that's what's filling up the queue. And as responsible engineers, we've also deployed some alarms and monitoring, such that if, for instance, a message gets stuck in the queue, there's an alarm that will go off that will send a notification to an SNS topic, and then we'll go to an alerting system to get developers involved. And of course, for anybody who's worked on AWS, you know that you have to have all these IAM policies to get the permissions just right. And as you can imagine, it takes a little while to get all this right. There's a lot of moving pieces here. It's not just a matter of putting together 15 lines of code and you're done. You have to kind of iterate to get all the pieces, the configuration right. And once you've done that, you want to reuse it. You don't have to do it again. You don't want to be copy-pasting YAML. You want to have this robust way of, I've done the work, I built the infrastructure, and now I want to reuse this event consumer thing across the board without writing more YAML. That's the really important part. So the first question we asked ourselves was, how does CloudFormation support reuse? The CloudFormation is a powerful tool. The people who built it are very thoughtful, so surely they've run into this problem, and yes, they have. In fact, there are a number of tools that CloudFormation makes possible, or makes reuse possible. Nested stacks, more YAML. Template snippets, more YAML. Custom resources, I'm guessing you can see the pattern here, more YAML. And then even serverless application model, which has done a fantastic job at making resource declarations much more concise, but nonetheless means that you're still living in this YAML world with all the problems that come with YAML. So at Stedi, given the choice between YAML and Clojure, we like Clojure. We want to write Clojure all day. So we had to broaden our question. Maybe CloudFormation wasn't the right tool for us, is what we thought. And we said, well, what are the alternatives in the AWS ecosystem? Maybe there's a better tool out there that we could be using that will help us solve the problems we want to do in a way that we want to do it. Well, it turns out, about a year ago, AWS released something called the Cloud Development Kit, or CDK, or AWS CDK is it's sometimes called. It's written in TypeScript, and it's this fantastic tool that allows you to be provisioning infrastructure without all the YAML. So if you go look at Amazon's AWS CDK webpage, they give you this example. To deploy a container onto a Fargate service, which is Amazon's container service, just a container, like a Hello World example. We're talking about this much YAML, plus 400 lines that I'm not even going to show you, or this much TypeScript. That's a huge difference. We're talking about 500 lines versus 20 lines to do exactly the same thing. Now, the way the CDK team has done this is that they've gone and looked at all the AWS service offerings, and they've created what they call the AWS construct library, which amounts to a lot of sane defaults. Rich primitives that solve the problems that most of us are working with in one way or another without having to worry about all the fiddly bits that CloudFormation makes possible to configure. And the construct library is basically an assemblage of infrastructure constructs. So this thing that I showed you earlier is also an infrastructure construct. And what's really powerful about that is you spend the time to build the infrastructure that is meaningful to your business or the problem that you're solving. You do that once, and then you can reuse it over and over and over and over and over because it is exactly this infrastructure construct. So not only are you getting this construct library that the CDK team has built, you're also able to define your own infrastructure constructs, as makes sense. So earlier I said the library was written in TypeScript. Some of you might be thinking he's about to recommend that I should take all my YAML and rewrite it in TypeScript. And honestly, you could do that, but I feel TypeScript is definitely an improvement, but I want to be writing Clojure all day. Well, it turns out, in addition to AWS CDK, there's this very interesting library that ships with it called JSII that allows the CDK team to choose their language of choice. They're working in TypeScript, but to be releasing bindings in Python, C#, and Java. Now, as soon as I said Java, a lot of you are probably thinking, well, why not Clojure? And that's what we thought too. So that's what we did. We open sourced a library called CDK CLJ about 2 months ago. It's been a fantastic experience, and I could continue talking about it, but I think at this point, well, first of all, I should tell you it's 100% Clojure, which is great. But at this point, I think it's really better just to show you what it looks like to interact with it and how to use it and so on. So joining me on stage right now is Tyler. He's going to walk you through a demo.
All right, thanks, Eno. Live infrastructure demo in the REPL. What could go wrong? All right. So my job is to give you all a sense for what REPL-driven infrastructure looks like and can be. And to do that, we're going to go through the process of deploying a Lambda that's going to run some Clojure code. It's going to be connected to a S3 bucket. So we designed this from the ground up to be a first-class REPL experience. We wanted to make it as easy as possible to get documentation, make it integrate with doc strings, make it so that you can get fast feedback when there's problems with your infrastructure, so that you don't have to go through that long feedback cycle of making a bunch of YAML changes, sending it off to CloudFormation, and then just hoping. All right, so the first command I want to show you is the CDK browse command, which is how you navigate to the documentation. So calling it without any arguments is going to take you directly to the opening page for the AWS CDK documentation. So this is primarily an interop library, so this is something very useful to have at hand. This is going to have the developer guide, which gives you a bunch of background information that's super useful when working with CDK. And it's going to give you the API reference, which is going to give you basically a holistic view of all of the packages and constructs that are available to you. So constructs compose lower-level CloudFormation resources. So there's always an escape hatch to using the lower-level resources, but these are going to give you documentation for both those high-level constructs and lower-level CloudFormation resources. Okay, so let's start to build our infrastructure. And all infrastructure in CDK is a tree of constructs with an app construct at the root. So the other command, or the other function, is the import function. So this maps, since this is an interop library, to the JavaScript import command. So running this, basically, we're pulling out the app class from the AWS CDK core construct library. And when we do this, it does a couple of things. One is it makes the class resolvable in the local namespace. And then the other thing that it does is it makes the symbol an alias for the namespace that gets created behind the scenes for app. So app is going to have a set of functions around it, things that you can do with apps, and those are going to be in a namespace that gets created as a part of this import command. So if I evaluate app, you can see now that this is resolving to a JSII class. So JSII is that low-level interop library that's enabling us to do this. And in essence, this becomes our constructor to create an app instance, and this is going to form the root of our infrastructure tree. So I'm going to go ahead and evaluate that and give it an outdir. And at the lowest level, this is generating CloudFormation. So this is just saying where to put the CloudFormation at the end of the day. So it's going to go in the cdk.out directory. And because we've done this in Clojure and reified all of these, or interned all of these as vars and namespaces, we get things like doc strings. So we get the documentation for this construct in your REPL so that you can use it to make sure that you're doing the right thing. So I mentioned that import command does two things. So one is it gives us this class. The next thing that it does is it turns or it converts the app symbol into an alias for the namespace for app. So we can see that the app namespace is going to have a few functions in there, and these are a couple of examples of that. So we can grab doc strings for these functions as well. So you have, since it's an interop library, you have both a static and instance methods. So this is an example of a static method. You can tell that because it doesn't take this as an argument. And this is an example of a instance method, which is going to take this as the first argument. It's sort of similar to the Java interop in Clojure. Another useful way you can use this browse command is to jump to the documentation directly from a class. So I can pass in that class to that browse command, and I can jump straight into the documentation if you need to figure out how to use these things. So an app without any stacks or other constructs attached to it isn't particularly useful. So let's attach a stack to the app. And we're going to import that from the CDK core package again. And the way that we connect this to app is we call the constructor with app as the first argument. So basically, child components attached to their parents. So we can call this constructor, and we get an instance of a stack. And so now we've connected these two things, these two pieces of infrastructure together. So on these resources that we've wrapped, we actually implemented the iLookup protocol on it. So you can use keyword lookup with these things, which is going to come in handy later when we want to link all our resources together. So a stack is the minimum deployable unit of CloudFormation, but by itself isn't particularly interesting. So let's add a bucket to it. And while we're adding a bucket, I want to show you that some of the examples of the feedback you get. We have put specs on all of these things. So if you try and call one of these things with incorrect information, you're going to get a hard failure right away with like a spec assertion telling you exactly what you did wrong. So in this case, it takes a ID as a second argument, and it's requiring that to be a string. So you don't have to send this off to CloudFormation, wait 10 minutes to find out that. You can find it out right away. So let's do this correctly now and give an actual ID and bind it to our bucket. So at this point, we have a bucket attached to a stack attached to an app. But that's still not that interesting. So let's add a Lambda because they're all the rage these days. So we're going to have to import a few constructs to do that. So we're going to import duration from the CDK core namespace, code, function, and runtime from the AWS Lambda package namespace. And then we have a little bit of boilerplate here because we need to make a jar for this in order to deploy it. So let me just evaluate these. And while that's building, I'll jump over to the application code that we're going to deploy. Oops. So it's a really basic function. We're going to make, it's going to be a web handler. That's why we're returning a status code here at the bottom with a body. We're going to put an object on S3 and then read it immediately back. It's not particularly useful or interesting, but I want to show how we set up things like permissions and all of that. And we're also going to pass in a secret because I saw Gene Kim's talk this morning, and one of the bullet points was that doing secrets right is hard. So I want to show how that works in CDK CLJ. So let's connect our function together here. So I'm going to import one more library, or one more construct, which is secret value, which is how we're going to bind the secret. And we're going to set up our function here. So the way we do that is first we have to tell it where the code is. So above and beyond CloudFormation, CDK is going to take care of things like asset management. So we have to tell it where our code is so it knows what to upload to S3 so that it's resolvable. Next, we tell it the handler we want to use. So because we're using the Lambda library, they have this def lambda function that when we compile is going to generate a class named like this that implements the Lambda protocols, or interfaces rather. We have to pass in the handler name, and that just has to map directly to the handler name over here, or the class that will get generated. Next, we have to tell it the runtime. There's this runtime class that has all of the different runtimes as static properties on it from the interop. So we just want to use the Java 8 runtime. I'll just show a quick example of how you get feedback with this here. This is not a valid runtime. You're going to get a hard failure if you try and do that, and it's going to tell you, this is the set of things you can do. So you can use this to deploy Python, Node. In this case, we want Java. Next, I want to show you how we link resources. So we're writing to and then reading from a bucket in that code. So we need to pass in the bucket name, or it's ideal to pass in the bucket name because it's going to be dynamically generated. We didn't name it explicitly ourselves. So we pass that in as a reference here, and we can do that just using the keyword lookup. And in addition to that, we're going to pass in a secret. So this is a secret that I uploaded ahead of time, and this is just a reference to that. That's going to be passed into that Lambda and made available as an environment variable. The last couple of things are just setting a timeout and memory size so that we don't run into a cold start issue or minimize the impact of a cold start issue. So let's evaluate that to connect it to our construct tree. Next, we have to give that permission. So right now, we don't have permission to do anything with that bucket, or that function doesn't have anything permission to do anything with that bucket. And I think this is one of the places that CDK really shines. I mean, I don't know how many times I've seen or done myself set ** permissions on like a CloudFormation resource saying, I'll come back to that later after I fix this, and then never do. There's no excuse now. If you're using CDK CLJ, we should be granting fine-grained permissions to grant least privilege to follow best practice. So we do this with just the grant function here, and if you actually take a look at the bucket namespace, we get autocomplete for all of the options in there. So this is another reason why it was nice to build this from the ground up. For Clojure specifically, and not to use the Java version, having this autocomplete functionality makes everything very discoverable. So lastly, we're going to just make this available via REST API through API Gateway. And we do this with the Lambda REST API construct, which is very handy. I don't know if anybody has ever tried to set up API Gateway with CloudFormation by itself. It's not fun. Getting the deployments right, invalidating them, pushing it up again, getting all of the methods and resources correct is not a fun activity to go through. The last thing that we do is we call AppSynth, which is going to synthesize this into a CloudFormation template. So I just evaluated the whole buffer there so that we pull in all of these changes, and that's going to dump it into a CDK out directory, which is going to take care of our assets, and it's going to take care of building our template. So you can see a JSON version of the CloudFormation template it generates here. So I'm going to jump over the command line now and start the riskiest part of this demo, where we're going to try and deploy it. So before I do that, I want to run the synth command, because this is going to show us all the YAML we didn't have to write. I don't know about you, but I'd prefer not to write this size a YAML file. I don't want to do it again. It's not fun. And we get the leverage of having it build all of these resources for us through CDK. So this is going to take care of policies, roles, methods, all of the things that you'd rather not think about if you don't have to, the API gateway deployments, and generate it in a way that if it evaluates in the REPL, it should deploy because of that fast error feedback. So let's give that a go and see if we can actually do it. So this is another nice value add. So CDK, the tooling around it, there is a command line a program that they give you, and it's going to take care of your deployments, packaging your infrastructure, and all of that based off of your CDK declarations. One of the nice things it does is it gives you this nice review page for all of the permissions that you set up, so you can make sure that you didn't put ** in there out of frustration. So I'm going to go ahead and say, yes, I did intend to make those changes, and this is going to deploy. And while it's doing that, I want to jump over to a larger example, just to show you some of the patterns and what this looks like at scale. Unfortunately, this is not a working example yet. It is a deployable example, but the code side doesn't work yet. I got carried away with the infrastructure. I wanted to show off all the different things you could do. So you can see here examples of doing things like cron jobs by using CloudWatch events. You can see examples of using state machines and hooking those up. So we're pulling in a lot of resources here to show you examples of how to hook all of these things up. So I'm going to jump down to the bottom to show you some of the patterns that we use. Perhaps the most useful is just regular Clojure functions. It's very nice to wrap up these complicated constructs as simple Clojure functions. So in this case, we've wrapped up this entire stack, app stack, as a Clojure function. And this is very handy for things like environments. So right here, we have a stack for dev, and we have a stack for prod. And we can pass in different configurations for dev and prod, and use that data to basically make decisions about what infrastructure we want to turn on or turn off. So in this case, you might want to turn a timer off in a dev environment because you don't want to run that all the time. You want to run it manually when you're testing it. The other pattern that I want to show here is like wrapping up a common construct that you're going to use in multiple places. So Lambda function carries all of the common configuration, and it's used a few times in this namespace. And this is something that could be put in a DEPS project and shared across teams or even open sourced. So if you have common build tasks or if you have common pieces of infrastructure that are general concepts, you can just turn them into a function, put them in a package, and share them. Let's jump back to our deployment. And it looks like we've been lucky and everything deployed. So, this took care of uploading our jar, connecting it to our Lambda function. It created all of our resources for us, and we can verify that. And it spits out a nice URL for the API that it created. And we can just curl that. And this is going to be going through API gateway to Lambda, putting something in S3, reading it from S3, and saying, hello, conj. 2019. You could, of course, done that with YAML, but I think, I don't know, I prefer this way. All right, so with that, I'm going to pass this back to Eno to bring us home.
Thanks, Tyler. That was great. So once we started using this internally, we started seeing PRs land like this. Massive deletions. Look at that. These kind of PRs bring joy to my heart because we're doing exactly the same thing in fewer lines of code. We're making our code more understandable, more changeable, and I like that. So if you go look at what the CDK team has to say about the library and its benefits, they'll say, you can define high-level abstractions, you can organize your project into logical modules, namespaces, functions, whatever. You can share and reuse your infrastructure, which is a huge point. You spend the time to build it right once, and then you share it across whatever unit you'd like to. You're getting code completion with your IDE. That's CDK. CDK CLJ adds yet another bunch of great things to it, in my opinion. You're working with your infrastructure in the REPL, the environment that we know and love, with that fast feedback. You're getting spec checking at AWS CDK boundaries. So if you forgot a required parameter, you passed the wrong kind of parameter, whatever, you're going to get a nice spec error right there when you evaluate it in your REPL, not waiting 10 minutes to find out you screwed something up. And then finally, you're able to think about your infrastructure in the same language that you're thinking about your business problems, which to me is a huge benefit. Like I said, this is up on GitHub, Stedi Inc. That's a little bit hard to spell, but Stedi Inc. /CDK-CLJ. The demos or the examples that Tyler walked through are up there. Try it out, pull it down, let us know what you think. If you don't like something, you'd like to change something, we're open to features or pull requests, issues, all that stuff. Or sorry, not pull requests. We're not ready for pull requests, but definitely issues and feature requests. So we're Stedi. My name's Eno. This is Tyler. Thanks a lot, everybody.